Hey YouTube, I have a new video for you. I've been working with these analog circuits like this one that you've seen in my other video about making your own distortion pedal. But I recently bought a bunch of things on Dutch Craigslist. One of the things that was in there was this Arduino chip. I've been playing around with it a little bit. I was wondering if I could make sounds with it or even use it as a guitar effect. It has an analog read, which means we can read the guitar voltage, which is handy. But it also needs to be able to produce sounds if we want to make a sound effect with it for the guitar. And it can produce sounds. At this point I uploaded the standard melody thing that is in there. I've got it hooked up to my amplifier, and if I click reset, you hear that it plays the melody. So the question becomes, how does it make this sound? If we want a good guitar effect, we're going to need an analog sound, meaning that we can have different voltage levels, but this pin that this Arduino is connected to can only do on or off, so 5 volts or 0 volts in this case. The Arduino does have pulse width modulation, which you can control using the analog write command, but that doesn't change the voltage, it only changes the duty cycle, which means it's not fit to make sound with. So I have a few ideas on how to do this, but first let's just hook up the guitar, and I'm going to try to just uber distort it basically. I'm going to say it's 5 volts when the guitar gives a positive voltage and 0 if it's a negative voltage. Okay, so I made my Arduino code here. My guitar is in pin A0. I'm writing to the serial. I'm just printing out the analog read that the guitar pin sees. If I play my guitar, I don't know if you can hear that. You can see it goes from 0 or 1 to about 10 if I play a soft note. All the way up to about, I don't know. Maybe I can write a quick code to see the biggest value. I don't know the syntax. Help guys, I have no idea what the syntax is. Oh, this seems to work. Let me press the reset button. Now it hovers between 1 and 4. Then when I play a soft note, it goes all the way to 6. Louder note, 15. And even louder, 44. And then if I really ram on it, it can go up to 240. I think the max is 1000. If you have 5 volts. Let me just quickly plug it into the 5 volt line. I'm grabbing a jumper cable and I'm putting A0, touching it with my finger. My finger is at 300. And if I plug it into the 5 volt line, yeah, it goes all the way to 1000. Which means our guitar goes to about a volt. And that is actually what we found with the peak detector. Don't remember what we found in the other video, but this is probably a better way to test the guitar voltage. And now we already see our first problem, and that is that we can't read negative voltages. I'm gonna swap to my camera and then I'm gonna show you how we're gonna fix this. So we can't read the negative voltage from the guitar. To fix that, of course, we're going to use our old friend. And our old friend is, of course, the voltage divider. If you've been watching this channel for a bit more videos, you've seen me use these all the time. So I'm not gonna explain them here. What I'm gonna do is, I'm plugging in my guitar through an AC coupler that's going into the middle of this potentiometer. And the edges of this potentiometer are going to go into the high and the low voltage. So I have my Arduino powering my breadboard. So what this voltage divider is going to do is it's going to balance my guitar signal around 5.5 volts. And what it's gonna do to our signal, when I put my signal read pin in the middle of this voltage divider, you will see on the program in a bit. So I added a min value, which starts very high, and then we also print that. And if I upload this, I don't know how to write. Now if we look at the monitor, we see it's balanced around 500. And then if I play my guitar, min is 440, max is 540, which is lower than I expected. First we had a swing of 200, and now we only have a swing of about 80. But maybe, I think this might still be good enough to work with. Our next goal is for the Arduino to make a sound. So I'm going to connect my speaker up to pin 2, pin mode output. And we're going to check the guitar every tick. If our guitar is larger than 504, so that we don't get buzzing noise if we don't play anything. Digital right speaker high, and then the same thing for 496, and then low. So this will just distort our signal a lot. I'm just going to run it and let you hear it through my laptop microphone. It's gonna sound horrible, but it's not gonna sound pretty in real life either. So, okay, let's hear it. It seems to just make a horrible noise. How interesting. What I'm thinking is that maybe the fact that we have our serial running ruins the clock rate of the Arduino. Okay, next possibility. What if I have to AC couple the speaker? Why would it make this horrible sound? Let me try pin 4 because pin 2 is being a bit weird. I forgot to say is lower than here. So I was bug fixing and I had the stupidest syntax bug. I had a colon here, but I removed it now and hopefully you can hear the guitar. This is my guitar being played through the Arduino. So you might hear, I don't know if you can hear this, but there's this sweeping sound going through it. Also just a lot of noise. I have no idea what the sweeping sound is. I don't know if that is my guitar or it's my audio amplifier that doesn't like the ground of the Arduino. But it's not a bug in the code because it also has it on pins when the code is not running. But it is recognizably a guitar. All in all, not too bad. So what do we have now? We have our guitar coming in. It goes into a voltage divider. And of course, it's AC coupled. That goes to the analog read pin A0 of our Arduino. And that reads our guitar signal. This goes to 5 volt, this is ground. Our Arduino can only go between 0 and 5 volts on its output pins. We hooked up the speaker to pin number 4. And we told the Arduino to go to 0 volts if our guitar signal is on the lower side and to 5 volts if it's on the higher side. If we draw a little diagram and we imagine our input guitar signal is a nice sine wave, then what the Arduino is going to do is from this point on it's going to go high, from this point it will go low, here it will go high again. This is called a 1-bit crusher. It can either be high or low. But what if we want our Arduino to be able to play more than one note? Oh, and I put a capacitor in here. In order to make a voltage that is not 5 volt, we can imagine that we have pin 0 and pin 1 here, and we can connect them through 2 resistors. We can make one resistor 10K and one of them 20K. And then connect this, and this will be our audio output. So let's think about what it's going to do. If both of these are at 5 volts, oh no, the sun. Blot out the sun. If both of these are at 5 volts, then this is obviously going to be 5 volt. So if this is going to be at 5 volt and this is at 0 volt, then this is going to act as a voltage divider again. And you see how useful this simple concept is at all sorts of places. But then of course, since this is 10 and the total is 30, we're going to have 1 over 3 times 5 volt. No, 2 over 3, of course, sorry. If this is high, then it's going to be 2 over 3. If this is high and this is low, it's going to be the other way around. Then it will be 1 over 3. If they are both low, then it's 0 volt. So in this way we can cut our voltage up into 4 steps. And we can tell our program to follow these 4 steps based on the signal level. Anyway, we can of course add more pins. We can maybe double the resistance every time. So if this becomes 40K, then this is still the most important one, and then afterwards this one, and you can kind of calculate whatever voltage it's gonna be, but you get the idea. We can use resistors like this to progressively make every other bit worth less voltage. And then we can make all sorts of steps from our voltage, and then we can maybe make a cleaner sine wave. And we can also make our guitar sound like an 8-bit instrument, which I'm very hyped about. This is currently my setup. It's a bit hard to see, but let me free cam it. I have 4 different resistors for each bit. And then I also have, these are the values that I used. I used a 4K, an 8K, a 15K, and a 32K. And then I used some 720K resistors, the blue ones, because I found that I needed to add a leakage current resistor at the pin exit that goes to ground. Otherwise they just didn't work properly. I don't know what the deal was with that. The pins I'm using are 4, 5, 6 and 7. Because 0 and 1 are apparently connected to the USB. I still have a very weird sound, sweeping sound in there. By the way, I made this nice drawer with all my components. That's where I keep the 1 farad capacitors. And I updated the code a bit. So there's of course only one question that matters, and that's what does it sound like? And that's how to turn your Arduino into a bitcrusher. Pretty cool. And this is with 4 bits. If you increase the bits, the sound will get cleaner. Let me learn how to play some Pokemon tunes or something. If you want to follow along with this project and anything was unclear or you're not figuring something out, just leave a comment and I will maybe make a follow-up video or I will respond to your question in the comment. For now, there's only one thing left to do. Can we get some Zelda in here? Okay, so this is a call to all viewers. I'm looking for the song in Zelda that goes da da ba dee da 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 dee. And that's the only part of the melody I can remember. I only played Link to the Past, but could be that I got it through cultural osmosis from Ocarina of Time, so let me know if you know in the comments. Okay, I did some final bug fixing. I changed the topology of the resistors. I'll show you my new design. Reason for this is I felt like the pins didn't really properly connect to ground, and because of that I felt like my signal was actually getting louder as it went on, which it's not supposed to do. After some bug fixing, I think I found a proper working design now. So if I click record now, you can see that in the old design the signal got louder when it was fading away, which it's not supposed to do. And that was because if we zoom in here, somehow some of the last bits from the signal were contributing way too much voltage. If we zoom into this signal here, I'm actually not using any capacitors in my circuit, but my audio interface probably has an AC coupling capacitor, and that's probably why you get these exponential decays here. I actually wanted to get nice clean choppy signals so that I could show you the choppiness, but that's unfortunately not gonna happen if we look at how the signal develops. If you kind of squint, you can see the stages that it has. Anyway, now it works a lot better. So now there's only one thing left to do. Oh, this is what it sounds like. Much cleaner. Now there's only one thing left to do. sorry, this video is starting to have more endings than the Lord of the Rings, but there's a few more things that I wanted to have said. First of all, this video of course is just a proof of concept. I haven't really gotten into making cool sounds with it yet, and I hope you are following along at home with your own Arduino, because that way you learn the most. And if you understood everything that I've done so far, your mind is probably brimming with ideas that you can do with this. I barely worked on any of the sound. Off camera I made a little low pass filter and a volume knob. I did a few more code updates. The most obvious effect that you can of course do if you have the amplitude crushing, you can also have a time-based crushing. And that will make your sound even more video game-esque of course. And that can be achieved with one line. I will show the code that I have here now. And the second thing you can do of course is to chain your signal with an analog signal, like the distortion pedal that I have here, that I made in another video. So now I have first the distortion pedal, then my bitcrusher. So this is what it sounds like with all of that. Quite crazy if you ask me. You should really do your own thinking about what effects you would make with this. In terms of all the things that I would like to do if I had more time, I will just put a list somewhere and you can take a look at it. Interesting. Yes, I definitely would have done that. So this is the real ending of the video. Thank you for watching.